What excites you more about the lab-grown diamond?
It is a very good thermal conductivity.
The unique quality is heat management. So where could we actually apply it in today's world?
Thin coating of diamond on the whole circuit. You don't have to put those heat sinks.
At what stage is the purity level evaluated during the production of an electronic grained lab-grown diamond?
We are injecting these gases, methane, hydrogen, nitrogen, oxygen. Their purity at the beginning stage is important.
How could we use our electronic grade diamond plates with an AI tool? In today's episode, we are going to talk about how electronic grade diamond plates can help with industrial challenges in an insightful and approachable way. As industries today are battling heat management and efficiency challenges, our current discussion is aimed to shed light on how lab-grown diamond plates can offer effective solutions to address this issue. We are honored to welcome Dr. Kailash Mittal, a retired senior scientist from BARC, whose years of experience and expertise will add value and depth to this conversation. He now lends his vast technical insight as an internal counsel for AGA9. We would like to know more about your journey, Dr. Mittal.
Thank you, Gargi, for kind introduction.
Thank you, sir, for being here with us.
I started my technical journey in the year 1974 when I completed my MSc Physics degree from Punjab University, Chandigarh. After that, I joined BARC training school, and since then, I have been working in BARC. So after joining BARC, I was assigned work in plasma physics division and electron beams.
All right. Okay.
So throughout my career, these two topics have been my field of work. It has been a very eventful journey for me. And as everybody knows that electron beams is a charged particle which is used in almost all the processes in the world,
Correct.
In the universe. And plasma is a state of matter which exists in more than 99% of the material in the world, not world, in the universe. So the matter, as we talked, it is in four states: solid, liquid, gases, and plasmas. And plasma state is most prominent. It decides several processes in industrial and other environments. Plasma plays a very, very important role in shaping the CVD diamonds.
Diamond plates, exactly. So that's what I wanted to come to. That what excites you more about the lab-grown diamonds? Because you know plasma plays a very important role in this, to growing a lab-grown diamond and to use it for various applications. And today specifically we are going to be talking about is electronic grade diamond plate.
Okay, this is a very, very good question. It needs some elaboration. Diamonds, as everybody knows, is a natural diamonds are available. They are very valuable and they are very expensive.
Correct.
And it cannot have large-scale applications. And most of the natural diamonds are used for jewelry purposes.
Correct.
Diamond has some unique properties which no other material has. Most of the material, rather all of the materials, have high thermal conductivity and electrical conductivity. They go together. If some material is good in thermal conductivity, it is good in electrical conductivity also. Diamond is an exception. It is a very good thermal conductivity, but at the same time, it doesn't have electrical conductivity.
Yeah.
So that makes it a unique element which can be used for heat spreading and withstanding high voltages. So this is a basic requirement in every electronic circuit. In not one circuit, in every electronic circuit.
Yeah.
This is a unique material.
Unique material. That's true. That's true. So my actually follow-up question would be, what qualities of lab-grown diamond plate that makes them perfect for electronic and other thermal management application? As you said, the unique quality is heat management for a diamond.
Yes.
So where could we actually apply it in today's world?
In today's world, heat spreading in all electronic circuits, you always see a heat sink connected to a PCB or some circuits. So that is for dissipation of heat. In case of lab-grown diamonds, if we give a thin coating of diamond on the whole circuit, you don't have to put those heat sinks.
Oh, okay. And you don't even have to switch off the system for a few seconds to cool it off or
not required.
Nothing like that.
It will spread the heat very evenly.
Very evenly. And so you think the longevity of the circuit or the machine would get better?
Much better. Much better.
Oh, okay. Where else can we apply these electronic diamond plates? Say, can we apply it in any machine right now in our something that we are using in our everyday life? Like a common man can use it in an everyday life so that his efficiency becomes better, it improves, and costing can reduce.
There are several appliances, several applications. One of them I just was reading, it is the solar cells. Solar cells given a diamond coating can improve efficiency of the power conversion.
So, with diamond coating?
Yes.
Okay. All right.
This is a research, latest data, but it has to be proven.
Oh, it has to be proven. So right now it's yet on the research.
R&D. R&D. It is on the R&D.
Okay.
But experiments have been done and some positive results are there.
Okay.
And secondly, it helps in protecting the top film of the solar cells, life of the solar cells, essentially.
So then why is it that people are not using it? Why is it that industry is not using it as much? As you know, everybody is much aware about the qualities of diamond, it being a great insulator, it being a great heat management material, as well as thermal conductivity is so high. And it is, of course, not cheaper than silicon, but it is cheaper than the rare diamond that you remove from the earth.
Yes.
So what is the reason that we are not able to replace silicon carbide with a diamond plate?
Yes, there are many technical issues in this.
Okay.
See, first is how do you make large size CVD diamonds? So there are 3 or 4 processes of making CVD diamonds.
Okay.
One, the most common these days is microwave CVDs.
CVD plasma.
Then hot filament CVD. And then glow discharge CVDs. And then arc discharge CVDs. All of them have different characteristics and their usability is different. So the most common is microwave CVD, which has a limitation of size. You cannot grow more than about 50, 70 millimeter 2-inch, 3-inch diameter crystals. But you can grow good thicknesses.
Yes, that's what we do at AGA9. That we are trying to grow 3 inches, but we can always grow as much thicker. What our challenges that we are facing is to grow it bigger, wider than 2 inches.
Whereas for this kind of applications, electronic applications, you need large size, but thickness is not very large required.
Correct.
So therefore, for this application, hot filament CVD is more suitable. Because size of the sample can be as large as you can make it.
Okay.
It can be 6 inch also.
Oh, okay. We can do that by the hot filament method.
We can do that, yes.
What are the other challenges while manufacturing electronic grade diamond, according to you, as well as how can we overcome them?
The question is, the CVD diamonds are made from methane gas and you use hydrogen and sometimes nitrogen and oxygen for making the gases.
For doping purposes.
Yes. Then the purity of all these gases is a major issue. Purity of the final product will depend on purity of individual gases.
Correct.
That needs to be highly pure. And then it needs base vacuum. Diamonds are produced in a vacuum environment. Typically, it is about 1 torr or 100 torr in that range.
Okay.
But in that range, when we are talking methane and hydrogen, there should not be any other gas.
Correct. So, vacuum plays a very big role in that.
Yes.
What kind of vacuum you're using?
Yes.
That's
so
true.
In case your vacuum is not as good, you are going to get impurities, which
Right.
will alter the characteristics of the electronic devices. So another point is for jewelry kind of applications, a vacuum of about 100 torr. 100 torr means about 50 to 100 torr range vacuum is good enough. That is what is normally used in all the CVD devices. But in case of electronic grade, you need to have a base vacuum of 10 to the power minus 6 torr. That is about how much? 10 to the power 6 times better than the normal
The
vacuum.
normal vacuum, yes, correct.
So that again is a challenge.
Yes,
it can be done.
And you need specialized labs. There has to
Yes.
be a particular lithography that you need to keep in mind when you are making that lab and then making the product in that lab.
Yes. It is possible to do it, but it is a bit difficult to do it, and it is more expensive also.
All right. My other I would want to ask you is, at what stage is the purity level evaluated during the production of an electronic grade lab grown diamond?
Okay, so the point is impurity and purity starts right from the beginning of the process. I need to put the conditions in such a way that there are no impurities.
All right.
To start with, we need to get a good vacuum. If you start with a poor vacuum, later on you cannot correct it. Secondly, once we are injecting these gases, methane, hydrogen, nitrogen, oxygen, their purity at the beginning stage is important. Later on you can't do anything.
You can't do anything. Okay.
If your impure gas is more than required, you can't do anything later on. So purity planning has to be
from the
right in
beginning.
the beginning.
And I have another thing to ask. Like you said that you did your PhD around 50 years back.
No, I joined 1974.
So you just completed your PhD and you joined.
My PhD I completed in 1986.
Oh, okay. All right. While you were working, you had completed your
Yes.
PhD. If you could compare that time and today's time, the education back then, in the 1980s, of course, it was very different because there was more theory. There was not too much of tools that we had to get better information, access to more, changes that are happening in the world at the same time. Right now, everything is there at the tap of a finger. What do you suggest today as a scientist to other scientists, that how can they overcome the challenges and what should they concentrate on? Because now with the AI coming into play, everything has changed. The entire game of not just manufacturing but also application of our products using AI. If you could put some light on that, like how could we use our electronic grade diamond plates with an AI tool? How could we do that? Do you think that's a possibility?
This is a very involved question, firstly.
Because nowadays everything is with AI. So I just thought of asking you that.
Yeah, it involves many topics.
Okay.
Firstly, let me tell you one thing is, in the earlier days, people used to understand basics. And nowadays, with the new kind of tools coming up, you don't have to understand basics.
Yeah.
Simply put some simulation code,
correct,
get the result.
Get the
You don't
result.
have to understand what is happening inside.
Okay.
So, with today's knowledge, people or workers or scientists, whosoever is working on a project, they don't understand why it is happening. If you want to make a new innovation, you want to make some change, you are not able to think what to do.
Okay.
Only
Okay.
computer will tell you.
Only
Only
computer will
AI
tell you.
will tell you what to do. But
Okay.
AI cannot give you all the answers.
Okay.
You have to use your brain also.
That's why we have you. That's why we need your counsel every now and then. So it's a good mix, right? Of like better the foundation, better the building on the top of it, right?
Yes.
So yeah, stronger the building. That's why. This has been super helpful and a lot of good insights. So one more last thing, Dr. Mittal, that what makes you so confident about AGA9 that we can make it? We can like get the success.
Good question. Looking at the progress so far in this location or in this group, I know that the quality of CVD diamonds made using microwave CVD has been excellent. It is much better than many other places in India. So with this background, I'm very sure that AGA will do a much better job, any project whichever they take.
Thank you, Dr. Mittal, for sharing your valuable insights on electronic diamond plates and its applications and demand in today's changing industries. Thank you once again.
Thank you very much, Gargi. Nice talking to you.
Same here. As we come to an end, the increasing relevance of electronic grade diamond plates reflects a broader shift towards precision, performance, and reliability in today's demanding industrial applications. While still in the early stages, AGA9 is advancing the development of electronic grade diamond plates, working together with our internal team and the outside lab. As we look ahead, our mission is clear to drive growth and increase market presence. Our long-term vision is focused on building new diamond-based products through continuous research and development. Stay connected with us for more details. Thank you.